Good afternoon. Just check voice is audible.
Yes, sir.
Yes, sir.
Where we were? Equilibrium rigid body. Second chapter we have started. Second chapter just we were started, not we just almost we are in at the middle of this chapter. Okay, so if possible, I think today only you got a notice of IEC 1 in semester exam 1. So for that IEC, this chapter will be there. So almost we will complete this chapter, I feel, within 4 or 5 days. So this one is the second chapter what we have started. Few lectures before. Okay, so we have seen what is equilibrium. This one is the syllabus, what we are observing on the screen. Further, we have seen the equilibrium. Okay, so into 3 lectures we have discussed what is equilibrium. It is nothing but when there are number of forces acting on a body, but body is at the rest, irrespective of number of forces acting on the body, irrespective of number of forces acting on a body, still body is at rest. That condition of body is called as equilibrium. Getting further, equilibrant, it is a force. Equilibrant is nothing but a force. It is nothing but force which keeps the body at rest. Okay, then we have seen what is the relation between resultant and equilibrium. Resultant represents force system, but equilibrium keeps the body at rest, that we have discussed. Then we have seen this difference. Single force that produces the same effect as that of all forces, we are calling it as a resultant. And on the other hand, equilibrant, it is a single force which when act with other forces bring set of forces and body in equilibrium. It acts instead of system of forces. It represents system of forces resultant, but it along the system, whenever there are number of forces, it will oppose the resultant, we can say, so that the body will remain at constant, or we can say at rest or stationary. Cause of displacement is a resultant, cause of stationary is equilibrium in short. Then we have seen free body diagram. Free body without forces, and free body diagram, a diagram of free body along with active and reactive forces. It's not only forces but active and reactive forces. Once we are going to show, we are going to call it as a free body diagram. We have seen how problems are becoming simple with the help of FBD. Conditions of equilibrium we have seen thereafter. How many are there? 3. So we know how we can find resultant. So as body is at the rest, resultant is equal to 0. So summation fx is equal to 0. Summation fy is equal to 0. And third one is summation of moment. We know the equation of Varignon theorem. Summation mf is equal to r into d. If resultant is going to be 0, automatically summation of m. So at the end, 3 conditions are there. So you can see which are there. Further, Lami's theorem. So we have discussed Lami's theorem. It is applicable to 3 concurrent forces which keeps the bodies in equilibrium. So if there are less than 3 or more than 3, we can't apply Lami's theorem. Okay, so that we have seen. How it is, the one of the force is proportional to angle between other two. One of the force is proportional to angle between other two. So that simple we can say. So that proportion will remain constant for all the forces. All the means 3. Whenever there is Lami's theorem, we should apply it for 3. Then we have some Lami's theorem, limitation and significance. Okay. We have seen only applicable to 3 forces, applicable when system concurrent, etc. Problems are becoming simplified, means advantage, calculation not tedious, easy to solution. Okay. This one we are going to require today. That's why I have taken this revision. After solving one problem, it is required. This one is most important thing. Okay. So what is that? Beam. It is a structural beam and column we have discussed. Beam are horizontal, columns are vertical. Okay, beam are the structural members, large body which carries different types of loads. It is supported by different types of structural supports for keeping its body in equilibrium. Definition: it is a structural member of a length which considerably more, means it is a lengthy element as compared to its cross section. It is a lengthy element that we can see. Next one is types of beam. How many are there? So this one is going to require today. That's why actually. How many types of beams are there?
5 types.
5.
Five types are there. Okay, simply supported, fixed supported, overhanging, continuous, and cantilever. These are the five types. Their description: why it is called simply supported? It is supported at the end only. That's why. Fixed supported, we cannot rotate. It is fixed. It cannot either. It can be lifted, cannot be slide, etc. That's why. Overhanging, ends are hanging. There is no support at the end. Support is there in between or between. That's why overhanging. Continuous, more than two. Not only at the end, but in between also. Continuous. And cantilever, fixed at one end, other end is cantilever. Types of support. How many are there?
4
4.
types.
Four. Simple, roller, hinged, fixed. Simple, roller, hinged, and fixed. So we have seen reactions also. In simple support, it is just simply kept. So what the way we have solved the problems? One reaction will be there. Roller support again only one reaction. At the end we have to show roller. Hinged support, two reactions. Hinged support, two reactions will be there. So it is fixed. Something like that. Hinged. It can rotate. Huh? When reactions will come into picture? A simple question I will ask. When reactions will come into picture? Whenever there is, when reaction will come into picture? Simple mechanics question. Or when a reaction will generate in a component.
When
More
there is
precisely.
action, then
Yes, whenever there is action or whenever there is a force and that component is resisting that movement, that displacement, that rotation, at that moment reaction will come. If there is a resistance in component, means in hinged support, there is no moment. There is no moment. Means this component may get rotated. Example दिलतं बघा, आठवतंय का तुम्हाला hinged support? Anybody is remembering? One of the example I have given during explanation. Anybody? Object can rotate, but it can't move. More precisely, I will say hinged support. So object move होते, maybe along with axis, whatever, one of the edge, etc. But it can't move. Horizontally पण तुम्ही move करू शकत नाही, vertically पण नाही. That's why reactions are generating. Example?
door.
Yes. Door, I have given example. Door can rotate along or we can say around one of the edge. म्हणजे डोअर काय होतो, फिरतो असा जागेला, पण तो आपण ओढू शकतो का असा बाजूला? Whether we can pull the door or push the door, something like this, maybe lift the door. If at all we won't do this, it may not be, means it is having resistance to that movement. This thing you have to remember. Whenever there is a resistance to movement or a rotation, not only movement but also for rotation, then there will be a reaction will come into picture. This simple thumb rule of mechanics we have to remember. When there will be action, there is a reaction. Fixed support, name itself is fixed. Neither it can move, neither it can rotate. That's why two reactions and one rotation, that is movement, will come into picture. Five types of beam. Sorry, yes, five types of beam, four types of support, and three types of what?
Load.
Three types of load we have seen: point load, uniform varying load. So this we have seen. Getting? So point load is applied at one point. Point load. Uniform distributed load. It is uniformly distributed. Okay, uniformly distributed, not between certain length. Uniform is there. Uniform. Actually, while solving the problem, we have to convert this uniform load as well as uniform varying load, UDL and EVL, into point load. It is necessary. It is required to be converted into point load. That we will see once problem we are going to solve. So can we say point load as a force? म्हणू शकू का आपण? It is something like force.
Yes.
Yes. Suppose you are sitting in your one of the room and there is a certain load of slab. तुमचा काहीतरी slabचा load असेल. Okay. Can we convert that slab load into point load? तर convert करू शकू का आपण? Is it possible? Point load is or load of slab, your slab. Okay. It is uniformly distributed. Means if you see a construction in civil engineering, that slab is it is but natural. It is not the case that some in at some places it is having more slab, more thickness of slab. At some cases it is having less thickness of slab. It will not be. Okay, practically speaking, it is uniformly distributed. So if at all, suppose you are sitting in one room, you want to convert the total load of slab into one point or one. Is it possible? So in that in that case, what you have to do? You have to calculate that load total, how much it is, and you can apply. For example, if you see here, this one is your slab. Okay, something like this. हा तुमचा slab आहे. So once you are going to calculate this load, total load you can calculate and you can show at this position, means where it is going to make intersection. At this position, you can show that vertically. So I can't show here that something like this. That we will see. Here certain formulas are there how we can calculate, that we will see further. How to convert UDL into point load and how to convert uniform varying load into point load. While solving problem, we must convert. Then only we can proceed. Otherwise, not. That we are going to see. Don't worry. Once that problem, we are going to start. Thereafter, we have solved problems. Okay. Some problems like this we have solved. All problems are solved. Some of I can manage to save. Some of the problems were not saved due to internet connectivity, or we can say power of in between. So whatever we have solved, it is with me in this way. Okay, so these problems already we have solved. Just I will take recap. The type of problems we have solved. It is with you as well. Simple problems. What is target? Our target is to get angle. And you have to check whether there are three forces. If there are three forces, definitely we can apply Lami's theorem and we can proceed. Okay, such problems also we have solved. Till now, there was only one object, but further to this, more than one object. How we have solved? These problems already we have solved. Just check. This one is also we have solved. And on that day, we came to this cylinder 1 of diameter 200 and cylinder 2 of diameter 300 mm are placed whose distance is okay. And we stuck at one point. We can't solve further equations because number of unknowns were exceeding number of equations. Can someone thought on this? विचार केला की याच्यामध्ये काय झालं नक्की? What was happened? आपण इथपर्यंत आलो होतो. Are you okay? We were up to this point.
वरच्या स्पेअरला रिएक्शन ते पकडलेच नाहीत त्यांनी.
हा सर बुक मध्ये पण तसंच आहे. पकडलेच नाही त्यांनी.
Actually, I have given, I have asked you to go because this problem I have told only, it was from the book. But as it is supporting, as it is going to touch at this inclined plane, means there should be a reaction. याला कोण चॅलेंज करू शकत नाही, because mechanics itself it is telling that whenever there is action, there is a reaction. There should be a reaction. So there should be a reaction. But in book it is not given. So it's a good thing. Those who have opened the book at least, they come to know that there is no reaction. Even I have thought on this. Okay. And then I come to one conclusion. मला एक इथं प्रॉब्लेम लक्षात आला की काय झालं असेल. काय झालं असेल हो? कोण लॉजिक सांगू शकते का? काय झालं होतं नक्की? Whatever we have did, don't worry. आपण जे काय समजून केलं इथं, one reaction we have assumed and we have solved. We have not did anything wrong. But there is a one basic, we can say, बेसिक थिंग गॉन इन टू रॉंग. त्याच्यामध्ये बेसिक चूक झालेली आहे या प्रॉब्लेम मध्ये. व्हॉट आय हॅव डिड. So is it the case means it is not the case that for one of the problem we can't solve means indeterminate. एखादा प्रॉब्लेम हा इनडिटर्मिनेट असू शकत नाही. सिम्पली मीन्स वी हॅव टू सॉल्व इट. सॉल्व्ह झालाच पाहिजे हा प्रॉब्लेम. बट वाय इट इज नॉट वी वेर नॉट एबल टू बिकॉज दिस वी कॅन से फिगर इज रॉंग. फिगर चुकलेली आहे. कशावरून ऑन विच बेसिस आय कम टू अ कन्क्लुजन दॅट दिस फिगर इज रॉंग. Because this top side roller or we can say cylinder, top side cylinder is not going to touch to inclined surface. मी म्हणजे असं हवेत बोलत नाही. What I have did, there is one software म्हणजे मी काय केलं एक vertical plane काढलं. I will show that in one of the software called AutoCAD. We are going to learn. If you are in mechanical civil, definitely you will learn. But as a part of syllabus also you are going to learn basic. मी काय केलं ही डायग्राम आहे त्याची आहे तशी काढली. Suppose I will ask you to draw this as it is. You may draw this by using circles, then scale, etc. by measuring angle. So what I have did, I will tell what I have did. Not here. तेव्हा इथं काय केलं बघा. दिसते फिगर.
येस सर.
काय झालंय बघा ऍक्च्युली थोडीशी ब्लर आलेली आहे. फ्रॉम दॅट सॉफ्टवेअर आय हॅव इम्पोर्टेड हिअर. जस्ट ऍक्च्युली असं असायला पाहिजे होतं. जर इफ दॅट टॉप साइड सिलेंडर हा जर टॉप साइड सिलेंडर आहे हा टॉप साइड सिलेंडर जर इफ इट इज गोइंग टू टच हिअर तो जर इथं टच झाला असतो तर त्याची रेडियस ही 93 पाहिजे. I have solved in this software, one of the software. So we cannot challenge software. Software is like something poison. Suppose there is one bottle, non-technical example I will do. Suppose there is one bottle and you want to check. Really is it poison? काय बोलू मग चेक करायचं त्याची खरंच विष आहे का काय करणार मग तुम्ही पिऊन बघणार का. Is it the case? We cannot. येते लक्षात. We can't examine the poison असं म्हणूया आपण. We cannot challenge software. आपण सॉफ्टवेअरला चॅलेंज करू शकत नाही because it don't have emotions. It is running on certain program. ते प्रोग्रामवर रन झालेला. It don't have emotion, human, etc. Nothing. मी जर म्हटलं सपोज ड्रॉ लाईन ऑफ 450 हिअर आय हॅव ड्रॉन. लाईन काढली 450. 450 असणार. डोंट वरी टू चेक. सॉफ्टवेअरवर शंका घ्यायची नाही की ती 450 चीच असेल का मग 449 ची कशावरून नसेल किंवा 451 ची कशावरून नसेल. इट शुड नॉट. वी कॅनॉट चॅलेंज सॉफ्टवेअर व्हॉट आय वॉन्ट टू सी. So what I have did, just I have tried to draw this in the software. Then I came to know that. So if this upper side cylinder is going to be touched to this lower side cylinder, inclined surface and this vertical surface, then it should have radius equal to 93. त्याची radius 93 असायला पाहिजे. पण आपल्याला प्रॉब्लेम मध्ये किती दिले हो
100.
100. Then what I have did in second case, what I have did, I have drawn that cylinder with 100 radius. मग मी 100 radius ला काढून घेतलं. At that time I came to know that it is not touching to the inclined surface. ते टच होऊच शकत नाही कारण ते जर ते परत तिथून खाली येत असेल तर त्याला 93 होत बनावं लागेल. Then it will touch to that bottom cylinder, inclined surface and vertical surface. Means are you getting what was the root cause? रूट कॉज ला कसं जायचं आपण एखादा प्रॉब्लेम आला आपल्याला हाऊ वी कॅन गो टू रूट कॉज. बेस मध्येच प्रॉब्लेम झालाय. आर यू गेटिंग. इन बुक ऑल्सो ओके. इन बुक ऑल्सो that reaction is not shown that at that particular point where it is touching. टच होतं तिथं काय केलं होतं रिएक्शन दाखवली होती का दाखवलेली
बुक
नव्हती.
मध्ये नाहीये सर.
नाही
बुक मध्ये
नाही दाखवली त्यांनी तिथं.
yes it is not shown but it is touching to the inclined plane. ते तर दाखवलंय.
येस सर.
इट इज शोन बट इट शुड नॉट. ते दाखवायला नको होतं कारण हे प्रॅक्टिकली शक्य नाही. प्रॅक्टिकली मी काढून पाहिलेलं आहे. 150 म्हणजे 300 डायमीटरचा सिलेंडर आणि 200 डायमीटरचा सिलेंडर 45 मधून अँगल घेतला हे दोन काढले ते टच होत नाही एकमेकाला. दॅट अप्पर साइड सिलेंडर इज नॉट गोइंग टू टच इनक्लाइंड सरफेस. त्याच्यामुळे तिथे रिएक्शन येण्याचा प्रश्नच येत. there is no question to come that inclined reaction for cylinder number 1. There is no question, don't worry. So this was the problem. So it will come back. तर इथं आरपी एक आपण पॉइंट घेतला होता बघा, हा आरपी येते का लक्षात, आरपी. so it will not come. हा आरपी पॉइंट येणार नाही बिकॉज इट इज नॉट गोइंग टू टच. तो टचच होऊ शकत नाही. it will not touch. Okay, so then in first, so we have to remove this rp. Once we are going to remove, how many forces will remain in FBD1?
3 4
Three.
Three.
Three forces. Three. Then that we can apply Lamy theorem and we can find. Are you getting?
Yes, sir.
Yes, sir.
Yes, we can solve this. So will you solve as a homework or we will solve here? हा प्रॉब्लेम काय आला लक्षात तुम्हाला, इथे टच होत नाही. इथे त्याला टच व्हायचं असेल तर त्याची रेडियस 100 पेक्षा कमी पाहिजे, लेस. आला लक्षात, तिथे आरपी रिएक्शनच येऊ शकत नाही. इट विल नॉट कम. Shall we solve this problem then without RP?
Yes, sir.
Okay, then we will solve this. So the same problem is here also, that same. So I will not draw. Let us go fast little. So FBD of cylinder 1. FBD of cylinder 1. You observe this diagram. This diagram carefully. So here there is no contact between these two. त्याच्यामध्ये contact नाही. Don't assume here there is a contact. Okay, so you can solve quickly, no issue. Chala. I am not going to edit that. So suppose there is a force. Sorry. Maybe something like this. How much it is? RA. Here is RA. Vertical is which force? How much it is? Can someone guide me? How much it is vertical? How much its weight? Can somebody guide me?
$800.
800
Newton.
800. So apply Lamy and tell me. So what it will become? RA divided by how much? Is it possible to find angle? RB. Whether we have found that angle? 45. How? आपण कसा find out केलता बघा. It is 45. So RA, angle between other two. How much it is? Sine 45.
Yes, sir.
Yes, sir.
RB divided by angle between other two. Sine 135. Then 800. Sorry, not 135. RB here 90. No?
90,
sir.
90. It will come 90. It will come 90. Okay. And here 800 divided by sine 135. Okay. So from this we can calculate RA equal to RB. Found out how much it is. Will you find? Are you with me?
Yes, sir.
How much it is?
RA 800.
800 Newton.
Yes, sir.
Yes, sir.
And RB
1131.37.
131.
113.
113.
1 113
1131.
1.37.
37.
37.
Okay. So these two we got, RA and RB. So let us go to now second FBD. I will write here FBD of cylinder 2. FBD of cylinder 2. So how it will be? Okay, this will be RB, no? Then what is its weight? I don't have problem statement.
1200.
1200.
1200 Newton. There will be one horizontal reaction as well. What is that? RC, no? This 150 arrow is of dimension. Don't take it with something other. 150. It is showing distance. That arrow. RC, and one more reaction will be there, no? Which is that?
RD.
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 RD. So RD will make how much angle with vertical? 45.
45.
Yes, sir. 45.
I will write 45. Okay. Then RB reaction making how much with horizontal? Then this one is RB. Horizontal. Let's check. 45.
Yes, sir. 45.
All the angles we got. RC 1200. 45. Okay. Can we apply here Lami's theorem for FBD2?
No.
No, sir.
No.
We can't apply. Why?
Because more
There
than
are
3.
4 forces.
More than 3 forces.
More than 3 concurrent forces are there. So let us apply now. Apply. What we have to apply then? If Lamy fails,
Conditions
Condition of
Condition of
equilibrium.
equilibrium.
apply conditions of equilibrium. Apply conditions of equilibrium. Which are the conditions of equilibrium?
Summation fx equal to 0. Summation fy equal to 0.
Summation fx equal to 0. Summation fy is equal to 0. How many unknowns are there now in this?
2.
Out of 4. Only 2. RB already we have calculated in first. So RC and RD. So which condition I should apply first, so that I will get at least one unknown out of 2. I have 2 equations, 2 unknown. It can be solved. Summation fx or summation fy.
Summation
RC is summation fy. So that which reaction it will not come in summation fy?
RC.
RC.
RC will not come. Only other 3 will come. Let us go now. So RB we have calculated 1131.37. So angle made with horizontal. Tell me y component of RB force or reaction RB. Y component of reaction RB. कौन सांगतोय फास्ट? Is it positive or negative? So is it going towards plus y axis or negative y axis? Positive or negative?
Negative Y.
Negative y-axis.
It should be negative. RB. RB we are knowing. How much? 1131.37. Angle made by reaction RB with horizontal is 45. So whether we have to take sine or cos?
Cos.
Angle made 45 with horizontal, we are taking y component.
Sine, sir.
Sign घ्यायला
Sine,
लागते.
sir.
We have to take sign. Actually, it does not matter. Here to me, at all you will make mistake here, sin or cos. It will not matter. Why? Because angle is 45. But as per our constraint, or we can say our logic, we have to take sign. So sin angle 45 made with horizontal, we are taking y component here. Next, RD. Is it going towards positive y axis or negative y axis? RD
Positive.
Positive.
positive. So it will be positive RD. Angle made 45 with vertical 45. It is with the vertical. So whether we have to take sine or cos?
Cos.
Cos.
Very good, cos. Then 1200 Newton, not 1200. Yes, 1200 Newton is going vertically downward. Whether we have to take plus or minus?
Minus.
Minus.
Minus 1200 equal to 0. From this, calculate RD. From this, calculate RD. Calculate how much RD is. How much it is? So it will come plus, then minus, again minus, minus, plus. I think value will be more. Just check. Because total its value will be
28.42.
2814.
28.42.
2828. Is it like this? Point.
42.
Okay. Others also. Actually, I don't have answer. Just wait, I will check. Others also. You please
Yes,
tell what
sir.
is the value. Yes,
Same,
correct.
sir.
2828. Yes, yes, good. Are you with me? Others also. Don't just copy the answer. Just don't see the screen only. You should follow it. So 2828.42. Is it correct?
Yes, sir.
Yes, sir.
Next. Next one. Summation fx equal to 0. Summation fx equal to 0. Okay. Who will tell me now? RB, force RB, is it going towards positive x-axis or negative x-axis? RB.
Positive x-axis.
First we'll take RB force. It's x component. What will be that? First, what will be that?
Positive.
Positive. 113.37. Sine or cos? Angle made with horizontal.
Cos.
Cos.
Cos 45. The next force. Let us take RC. Plus or minus?
Minus.
Reaction of
Minus.
minus. Okay, it is going towards negative side. Negative, or we can say left hand side. Next, RD. Is it going towards positive x-axis or negative x-axis?
Positive.
RD.
Positive x-axis.
But we have found RD. I will write that value here. So 2828.42 into angle made with vertical is 45. So what will be its sine? What will be its x component? Sine or cos we have to take here?
Sign.
Sine.
Yes, we have to take sine. So in this equation, what you will do? You can move that RC into other side. Just remaining term as it is, you can calculate which will remain at this side. So it will be okay. RC equal to nothing else. Calculate RC. How much it is?
2799.
799.99.
Just check. 27.
99.
99.99.
हा सर 2799.99.
Others, anybody got something other? Maybe my answer may be wrong then. Okay. What is 2799?
Yes,
Is
sir.
it correct?
Yes. 0.99.
Means almost it is 2800. You can say. Is it the case? Almost it is 2800.
Yes, sir.
Yes, sir.
Almost we can say only 0.01 is the difference. Almost it is 2800 Newton. This one is the answer.
हॅलो सर.
Ha. Ha.
सर ते आपण वरती लांबीच थेरम लावला बघा तिथं आरबी 45 डिग्री घेतला बघा व्हर्टिकल सोबत. ते थिटा 36.87 येते सर. ते डायग्राम मध्ये थिटा आहे बघा सर. बुक मध्ये पण तसंच दिलंय.
हा सर बुक मध्ये पण तेच आहे.
How we have calculated this? If it is the case, I have taken just yesterday's that given as it is forward. Then it may
आपलं काल पण चुकलं होतं वाटतं मग 45 आपण ते घेतलेलं. सर ते 100 मिलीमीटर आणि 150 मिलीमीटर रेडियस आहे. 45 येणारच नाही मग सर.
okay. Then it will okay. If that is the mistake, then it is our mistake. ते आपलं चुकलं मग. 450 minus 100 minus 150. So how much it will be? Means this horizontal will become how much? This horizontal will become how much? 450 minus 150. 300 minus 100. I think it will become 200.
200 सर.
Correct.
यस सर 200.
कॉस थिटा फाइंड करायचं सर
This
ह्यावरनं आता.
then it will become. This diagonal is already given. 100 plus 150 means
150.
it is 250.
250.
Okay, 250 means in this triangle, what we know right now? Okay, adjacent side is known, not adjacent. Yes. So for this theta, adjacent and diagonal we know. Is it correct? No. So we can
Yes,
find
sir.
theta.
Yes, sir.
Now, if this is the mistake, then that is our mistake. We should not blame to the problem. Theta equal to cos inverse of how much? 200 adjacent divided by 250. किती येते बघा बरं हे theta?
36.87 सर.
येस सर.
87.
36.87.
सर आपण थिटा घेताना चुकलो आणि त्यांनी प्रॉब्लेम देताना
One mistake we have committed, one mistake that problem is committed. Good. You take homework and with this theta you continue. एक पेज थोडस मध्ये. We will not waste time now. One of the mistake what I found that it should not touch to the inclined surface with 100 radius. It will not touch definitely. If at all it want to touch, it should have 93 radius. And here while making calculation we committed mistake while calculating. I don't know then from which background we found that 43. इथलाच अँगल आज प्रॉब्लेम सोडवताना मी डायरेक्टली इथला घेतला. Looking to this, maybe we have applied logic on that day something. Maybe it might have gone wrong. So in this case, this problem is solved there. Actually, in book you can solve this. Only this check this theta, and you can continue. Okay. Procedure is same. Theta just you have to check. Nothing else. You can take help of book. Okay. Actually, this one is very rare to rare. Rare to rare. It is something like 2020 match. Okay, 2020 match सारखं झालं आपलं. In last over, many more things are going to happen. Okay, maybe that.
सर हे मग
20
53.13 येत आहे सर थिटा हे आपण 45 घेतलेलं.
and that then we have to do minus. ते minus करावं लागेल ना तुम्हाला. 36 पॉईंट किती आलता मगाचा आपला?
36.87 आलं होतं सर. 90 minus 36.87 करावं.
मग ते 90 minus करावं लागेल ते vertical शी. With this you can solve. त्याच्याशी करा solve as a practice. Here you can take. You can solve. Okay, actually this rare problems, a rare problem आहे. It will not come. Other divisions when I have asked you, nobody has taken this much complex problem. इतकी complex कोण गेलेलं नाही. But let us see. We are having time, so little we will go little depth. One or two hardly. We are far ahead than others. We should not compare with others, but we are ahead. Don't worry. So as a practice, you can solve. It is solved the problem from that which one? Quasi book. Okay. Today, now hereafter, beam problems are going to start. Problems on beam. So that's why I have taken revision initially. We should know types of beam. We should know that what types of beam, types of load, types of support, etc. So now from this beam problems are going to start. Okay. So first problem from the beam. Do next heading. If you want, you can skip one page to solve that earlier problem. If not, use this title. Calculate reaction of beam of following loading analytically. Are you able to see diagram?
Yes sir.
Yes, sir.
So one beam is given actually. Which type of beam? So here I will give name A. I will give name as B here. Okay. So at how many places this beam is supported? किती ठिकाणी support दिलाय?
Two.
AB. It is shown by line. At the end again, at the end. So what kind of beam it will become?
Simply supported.
Fully supported.
It will become simply supported beam. And whatever reactions are offered means at two different places force is applied on this beam. At two different places. So whatever load is applied on the beam, it will be taken by two reactions. Okay, so we can say it is RA and RB. RA and RB. So what it is given? Simply supported beam. Simply supported beam AB. Okay. And to find reactions, to find reactions RA and RB. To find reactions RA and RB. We are supposed to find reactions RA and RB. Okay. So let us see now how we can find that reactions. So two forces are applied. So as there is a beam is not going to rotate, or we can say displace from one place to other. So always we have to remember this. एखादा beam असं इकडे तिकडे जातो का कधी? It is not. It is always in equilibrium condition. So here we have to apply conditions of equilibrium. Apply conditions of equilibrium. So let us see. Which conditions we should apply here? Suppose we will apply summation fx equal to 0. Fx. Is there a horizontal force in this beam? Second, horizontal, it may not be horizontal, but is there a horizontal or inclined force?
No.
Not a single force which is horizontal or inclined. All the forces are vertical. So there is no use of summation fx is equal to 0. If at all you will try, it will not help you because no any force is horizontal or inclined. So what do we have to do? Which we have to equation apply? Summation
Fy.
Fy equal to 0. Summation Fy equal to 0. So what will be that? Now that Ra and Rb reactions you have to consider as a one force. So how it will become? Ra is going upward, means it will be positive or negative?
Positive.
Positive.
Positive. Then Rb again positive. What about this 60?
Negative. -60.
Negative. Negative minus 30 equal to 0. From this what we can get? Ra plus Rb equal to काय value?
90.
90.
Equal to 90. Now summation fx we can't apply. Summation fy we have applied, but we don't got anything. Which condition is remained now for equilibrium? Which condition is remained?
Summation of movement due to all forces.
Summation of moment due to all the forces is remained. So let us apply that. Where is my cursor? Yes. Now apply summation of moment due to all forces. At what point we have to take forces or moment? At what point we are supposed to take? In between point, at point A or at point B? कुठे घ्यायची
At
moment?
point A.
At point A.
At point A.
Why?
Lower.
Lowermost left point.
Hmm, it may not be the logic. If at all we want to find, आपल्याला ते aim काय आहे इथं? What we are supposed to find here?
Reaction of beam. Reaction of
Reaction at point A and B. Reaction at point A and B we are supposed to find. Means we have to take such point through which at least A or B should pass. म्हणजे तुम्ही असा पॉइंट सिलेक्ट केला पाहिजे की त्याच्यामध्ये या दोन्हीपैकी एक काहीतरी झिरो झालं पाहिजे.
Sir.
आयदर ए ऑर बी.
मग कोणताही घेतला तर चालेल ना सर दोन्ही
हा सर ए नाहीतर बी कुठलं पण.
कोणताही दोन्ही पैकी एक.
Anything. You can take anyone, either A or B, but not this intermediate. हे intermediate जर घेतले तर परत दोन unknown येणार तुमचे त्या equation मध्ये. It may come again two unknowns. So again complexity will increase. Already one equation we are having, we can solve, but complexity will increase unnecessarily. So for that purpose, you have to take one point at which one of the force will become 0. Okay. So I will take suppose A point. Summation of moment at point A is 0. So let us calculate this now. Our desired point now A, point A. So what will be the moment due to reaction Ra at point A?
0.
It will be 0. So not necessary to consider. Next, 60 Newton force. How object will rotate due to 60 Newton force? Now how this beam will rotate? Actually it is not rotating, but due to that force, how it will have rotational effect?
Clockwise.
Clockwise.
And clockwise moment we are taking in positive or negative?
Positive.
Positive.
What is the distance of line of action of 60 Newton force and point A?
3 meter.
3 meter.
3 meter.
3 meter. The next force 30 Newton. How object will rotate?
Clockwise.
Clockwise.
Again clockwise. So 30 into
6
6
meter.
meter.
okay. Then RB. If at all we will apply
Anti-clockwise.
anti-clockwise, RB into
8.
8.
8 equal to
0.
0.
Zero.
Therefore, RB equal to, just take RB to this side and calculate this. 60 into 3, 180. This, I think again it is 180. 180 plus 180, 360 divided by 8, 40.
45.
Huh?
R equal to 45.
45.
Yes, sir.
45.
Sir.
Are you with me?
Yes, sir.
Okay, from equation 1. From equation 1. What is equation 1? Ra plus Rb. Value of Rb we have calculated. 45 equal to 90. Which will give? What it will give? Ra equal to how much?
45.
45.
Just check. Huh? Okay. So Ra and Rb 45. Can someone have one observation? थोडस observation करून बघता का की काय झालंय नक्की या प्रॉब्लेम मध्ये? Problem is correct, don't worry, but I want to know a little observation.
सर ते वरतून 4 असं आलेलं रिॲक्शन सम दोन्ही इक्वल असतंय.
Yes, it should be. It should be. That I want to know. किती फोर्स अप्लाय केलाय या बीम वरती टोटल? 60 plus 30. किती झाला?
90.
90.
90. आणि रिएक्शनची बेरीज किती झाली? Ra plus Rb?
90.
90.
90.
Again it is 90. Means it is balancing. That's why this beam is in, काय म्हणायचं? That's why this beam is in
Equilibrium.
equilibrium. असे क्वेश्चन विचारले होते बघा. Maybe in last MCQ. Suppose 120 force, 120 Newton force is applied. And here there is, or multiple choice question. And here there is Ra and Rb. Very simple. From this, you were supposed to find Rb is equal to how much? 120 Newton's of force exactly at the center. It is applied. किती असेल मग Rb equal to?
60.
60.
60.
It will be 60. It will be 60 Newton. अशी क्वेश्चन विचारले जातात MCQ ला. व्हेरी सिम्पल इन दिस वे. असा विचारलेला होता मागच्या वेळी एक क्वेश्चन युनिव्हर्सिटी. व्हेरी सिम्पल. वन बीम at the center load is applied, so it will distribute half on both the supports. Okay. So it was just a simple one, but likewise now hereafter we have to apply third equation, that summation of moment due to all the forces is 0. This we should apply hereafter, so that we will see. Shall I give one problem for homework?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. This beam, second beam, you can read problem statement. Just what it is given, a beam of total beam is length is 400. So here point A is there, point B is there. Okay, point A and B. And here which type of load is this? Whatever it is applied.
Uniform distributed load.
Yes, uniformly distributed load. So what we have to do while calculating, we have to convert that uniformly distributed load into point load. आपल्याला त्याला point load मध्ये convert करावं लागतं. How? Just see here now. Or how much long or how much length that force is applied? किती लेंथ साठी होतो युनिफॉर्मली डिस्ट्रीब्युटेड लोड?
2 meter.
2 meter.
2 meter.
2 मीटर. आणि त्याची इंटेन्सिटी काय हो? इंटेन्सिटी मीन्स पर मीटर किती येतो? प्रत्येक मीटरला
10
किती आहे?
kilonewton per meter.
10 किलोन्यूटन पर मीटर. मग टोटल किती झाला लोड सांगा बरं मला 2 मीटर लेंथ वरती?
20.
20.
येते का बघा? हाऊ वी हॅव टू रीड. कसं रीड करायचं लक्षात आलं काय? पर मीटर
Yes,
म्हणजे
sir.
प्रत्येक मीटरला किती आहे? 10 किलोन्यूटन. So for 2 meter it will be 20, or if you are not understanding, that UDL load into length. दोन्हीचं मल्टिप्लिकेशन करा, you will get that point load. And how to convert, we will see just see now. And we have to show that point load at the middle of that particular length, not total length, that particular length. मग कसं येईल बघा बरं. Then how it will come? So here it is a 15 kilonewton. Here it is 20 kilonewton. And this, if you have to show half, म्हणजे त्या 2 मीटरच्या बरोबर मध्ये ठेवायचा हा फोर्स. In this way, it should be at the middle. And how much will be its point load? 20 kilonewton. And what will be this distance is then? हे distance किती असेल हो? 20 kilonewton पर्यंत 1 meter.
Yes, 1 meter.
Yes, sir.
Yes, sir.
Again 1 meter.
1 meter.
Again 1 meter. And this will be again 1 meter. And this total is how much?
4
4
meter.
4 meter.
4 meter. Since this problem we have converted into in our simple problem. Now you can find reactions A and B. Now you can find RA and RB equal to how much? Try to find. If not, tomorrow we will find. Don't worry. Okay. Shall we stop then for today?
Yes, sir.
Just wait. I will take attendance. Roll number 2 is absent. 12 is absent. 2, 12, 1. 22 is absent. 22. Okay, 3 are absent. 2, 12, or 22. 2, 12, and 22 are absent. Remaining are present. Thank you very much.